All right. This one we have, it's what's called a roll-off problem. And we have a height here. So this is going to be y. That's how high the table is. And it lands 3 meters away. So if we draw the table, the ball is going to be going this direction. It's going to land over here. And that's what this distance, we're going to call that. X is 3 meters. That's how far away it's going. The 1 meter is the height of the table from the table to the floor. And it says, so the first question is how long is the ball in the air? So what we're looking for is time. We have VI in the Y direction. We have VI equals 0. We don't have VF. We have A equals 9.81. We are looking for time, and the Y is 1 meter. Since we have 1, 2, 3 variables, we can go ahead and solve for time, figure out how long till it hits the ground. That's going to be Y equals VI t plus 1/2 AT squared. Since VI is 0, this cancels out of the problem, simplifying it to Y equals 1/2 AT squared. This is true on all roll-off problems because VI is always going to be 0 when it rolls off the edge of something. So what I want to solve for is t. So I rearrange that. It comes out to be 2YA. Take the square root, and that's going to equal t. So 2 times 1, which is y earlier in the problem, divided by a, which is 9.81. And I take the square root of that whole thing, and that's going to equal, so that's 2, 9.81, divide, and take square root. I got 0.45 seconds. And that's what the answer up here says it calls for, so we must have done that one right. All right, B says, what horizontal velocity did the ball roll off the table with? So what we want to know this time is the ball is traveling this direction. We want to know Vx. On the x side of the equation, the only thing we have for that is velocity x equals x divided by t. So t, we discovered a moment ago, was 0.45. That's the same for both sides, 0.45 seconds. And what else do we have? We had x equals 3 meters. So since we have x and we have t, we can just plug it in. It's 3 divided by 0.45. .45 divide, and I've got 6.6. So that's going to be the speed that the object was traveling horizontally when it left the edge of the table. So that answer is B. All right, C, what is the vertical velocity? So what they're talking about is this, just before it hits the ground, is VF. That's on the Y side. Whenever they talk about vertical, they're talking about something on the Y side. So over here, I've got 0.43. I've got 9.81. I've got all the variables except for the final velocity. So I could use any of the who cares equations. Simplest one is one that's already solved for VF equals VI plus AT. It's in this case VI is 0, so that cancels out. So it simplifies to VF equals A times T. So all I have to do is take 9.81 and multiply it by 0.45, And that's going to give me the final velocity of 0.45, 9.81, of 4.4. So the object rolled off the edge of the table, started to fall. The moment it struck the ground, that's what we solved for, is the final velocity right as it struck the ground would be 4.4 meters per second. The last question is, what's the horizontal velocity of the ball just before it hits the ground? Well, it's exactly the same as the horizontal velocity when it left the edge of the table. The point is that the velocity of the ball when it leaves the edge is constant always in the x direction. That's the only reason that we can use a simple equation on the x side, is that it's a non-accelerating thing. It doesn't speed up, it doesn't slow down. So you can use the velocity equals distance over time.